Hello students, so let's have a brief discussion about electron spin resonance spectroscopy. This is a chart presentation that I have made. Let's go through one by one, starting with the introduction part. ESR spectroscopy. It was discovered by Zavorsky in 1944. It is also called electron paramagnetic resonance, that is EPR, or electron magnetic resonance EMR. It is a branch of absorption spectroscopy in which radiation having frequency in microwave region, that is 300 MHz to 300 GHz, is absorbed by paramagnetic substance to induce transition between magnetic energy level of electron with unpaired spin. So basically, what is a paramagnetic substance? Paramagnetic substances are weakly attracted on magnetic field, right? So due to the presence of one or more unpaired electron. If you take iron or oxide or oxygen, cobalt, nickel, and other transition metal components, these substances have one or more unpaired electrons, right? So if you take nickel has two unpaired electrons, so it is a paramagnetic substance. These paramagnetic substances are basically absorbed in the microwave region to induce transition between the magnetic energy level of electron with unpaired spin. It deals only with unpaired electrons or free radicals, which can be organic as well as inorganic. The types of substance with unpaired electrons that are ESR active is atoms having odd number of electrons are ESR active. Ions having partially filled inner electron shells are also ESR active. Molecules that carry angular momentum of electronic origin, free radicals having unpaired electrons, and molecule with paired electrons and zero magnetic field. These are all types of substance with unpaired electrons which can be ESR active. Let's go to the principle now. It is based on the absorption of microwave radiation by an unpaired electron when it is exposed to a strong magnetic field. The electronic energy level of the atom or molecule will split into different levels. The magnitude of the splitting is dependent on the strength of the applied magnetic field. So if you take a look at this diagram, energy diagram, you can see a BZ is a magnetic field. When magnetic field is 0, when we don't apply magnetic field, the magnetic spin of an unpaired electron will be plus or minus 1 by 2. It will be in degenerated state, right? So if the electron spins in plus or minus 1 by 2 state, when there is no magnetic field, it will be in degenerated state. When we apply magnetic field here, when B does not equal to 0, energy level splitting takes place. So energy difference takes place. That difference is delta E. Delta E is equal to H nu is equal to G Bz mu B. Mu B is Bohr magneton here. Bohr magneton is nothing but the strength of the magnetic field for a particular electron, for a particular electron spin. And H is a Planck's constant here. Mu is frequency, and G is Land splitting factor, or which can also be said as spectroscopic splitting factor. We'll see about this later. Okay. So when the energy difference takes place, that is delta E, right? When we pass magnetic field, microwave frequency will be passed perpendicular to the magnetic field. So the electrons is absorbed and goes to the higher state, that is plus 1 by 2. It goes to the higher state, that is resonance. When it goes to the higher state and comes down to lower state, it emits frequency. That frequency will be in microwave frequency. So you know that in NMR it will be in radio frequency, right? So in ESR it will be in micro frequency. This is about the principle of ESR spectroscopy. It is nothing but unpaired electron that are excited to higher energy state under magnetic field by the absorption of microwave. The excited electron changes its direction of spin and relaxes to the ground state by emitting photons. So this is the basic principle behind ESR.